Hi guys. Okay, so this is the last part of chapter 1, which deals with the conversion factors and converting in between the units. So I just want to do a quick review once again about the prefixes. So these prefixes, as you can see, two parts. One is the ones that increase the size of any units, and those units could be in lengths or in mass or in volume. And the prefixes can also decrease the size of units. And again, those units could be, anything. So here we see that one thing that I want to point out is 10 to the power 3. Now, what is the meaning of that? This means this can also be written as 10 times 10 times 10. Okay, so that's how you get 10 to the power 3. And this means 1,000. Okay, so kilo, wherever you will have kilo would mean 1,000. Okay, so that's one thing. Then mega is 10 times 10 times 10, and then 10 times 10 times 10. So it's like 6 times. So this is 10 to the power 6 and 10 to the power 9 and 12. So that's how we get that. Next thing, the ones that are smaller in size, these you are going to be dividing. So these guys, the ones that are larger, you are multiplying them. So I'm going to just put this here, that you multiply these, by whatever number is there, you multiply with these 10 to the power 3, then you get kilo, 10 to the power 6, so forth. Okay, so then also there are the base units. The base units are like standard, and then everything else is in relationship to them. So in terms of length, meter is the base unit. In terms of mass, kilograms is the base unit. For time, second is the base unit. And then you will study more about the amount, which is the moles, is the base unit. Okay, now let's look at the prefixes that decrease the size of the unit. So here, 0.1, this means 1 over 10. So in other words, when you multiply something by 10 to the power negative 1, in reality, you are dividing it by 10. Okay, so similarly, 10 to the power negative 2 means 1 over 100. 10 to the power negative 3 means 1 over 1,000. Okay, and then 1 over 1,000 relates to 0.001. 1 over 100 relates to 0.01, and 1 over 10 relates to 0.1. Okay, and then similarly, you can go one more, which is 10 to the power, say something, you have 10 to the power negative 4, just for the sake of 10 to the power negative 4. So 10 to the power negative 4 would mean 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. Okay, so this also means that 1 over 10,000. Okay, 1 over 10,000. And 1 over 10,000 can also be written as 1 multiplied by 10 to the power negative 4. Okay, so this is a little bit I wanted to, touch base with the math piece. Now let's look at our next chapter, the next section, which is on the conversion factors, that is converting between the units. So I had to go back to the prefixes to just get you refreshed on what does K kilometers or K alone stands for kilo. So kiloliters, kilometers, kilograms, so again, that's the base unit. So for mass, so now 1 kilometer, kilo means 100,000. So that is why you see that you have 1 kilometer is 1,000 meters, and meters is our base unit. In kilograms, so 1 kilogram is 1,000 grams, because kilogram is the base unit. So here, anyway, so 1 kiloliter is 1,000 liters. So anytime you have kilo, 1,000 is added to it. Okay, now when it comes to centi, 100 is added to it. So it's 100. So 1 meter is 100 centimeter. 1 meter is 1,000. So these are the equalities that are in the metric system. Okay, so 1 centimeter is 10 millimeters, okay? And then 1 liter is 10 deciliters. 1 liter is 1000 milliliters, and 1 deciliter is 100 milliliters. So these are basically the equalities when you need to convert in between the prefixes. So this is how, you can use this. All right, so just keep in mind that um, the the which of them are the smaller units and which one of them bigger units. Okay, so some of the things are not very clearly explained in the book, so I highly recommend that you just pay attention to this and feel free to take notes as you want. Now let us say we want to convert in between these units, and let us say we have one example. 1 meter is equal to 100 centimeter, and we are given a problem, which is 3.5 meters is how many centimeters? This is what we need to find. Okay, so 3.5, this is our problem. So the way we set up the conversion factors is the number that is written on the top is numerator, the number that's written at the bottom is the denominator. So the number that's the numerator is the unit that you want. Okay, and the unit that is in the denominator is the unit that is going to be canceled out or removed. So here the unit that we want is 3.5 meters. No, sorry, so we want is the centimeters, but we want to cancel out the meters. So we want the centimeters, but we want to cancel because we want to convert, in other words, cancel the meters, or in other words, convert meters to centimeters. This is what it means. Okay, so convert meters to centimeters. Now, how are you going to do that? So every time you use a reference, which is, we know that 1 meter is equal to 100 centimeters. So the two conversion factors of this is 1 meter over 100 centimeters, or 100 centimeters over 1 meters. Okay, so this means that now you write down your given. So the given is the entity that is given to you in question. The given is the one that you want to convert. Okay, so you are given 3.5 meters, and you need to find out how many centimeters is that. So the out of these two conversion factors, you see this conversion factor versus this conversion factor. So we want to cancel out the meters. So out of these two, we are going to use this one because the meter is placed in the denominator and centimeter is what we want. So centimeter is in the numerator. Okay, so now just solve this. So 3.5 meters multiply by that conversion factor where meters is in the bottom in the denominator and centimeters is on the top numerator. So we have 100 centimeters and this one is 1 meter. All right, so now meters and meters cancel out and you're only left with the unit of centimeters. So now we have 3.5 times 100 divided by 1. So what do you get here? Okay, so when you do this math, 3.5 times 100, you get 350 centimeters. So this is how you use a known entity, a known equality, which is 1 meter is equal to 100 centimeters. So this is known, and then you use an unknown, which was given to you, that unknown given. So given is really the unknown. And this unknown has to be converted to like a, made it into a centimeter from a meter. So 3.5 is given times you use the conversion factor, which cancels out the units. And this is how you set up the problem. Okay, now let's look at another examples where we are given the metric system and the US system, and then we convert these two. So again, this was discussed earlier, but these are just some of the equalities which are known. So 1 meter is equal to 39.4 inches. Again, either on the exam we're going to give you, or these are on the tables in your handouts, okay? Or you can make a note of it. Okay, so similarly, the two conversion factors in this case is 1 meter over 39.4 inches. Next conversion factor is 39.4 inches, 39.4 inches over 1 meter. Okay, 1 centimeter over 0.39 inch, or 0.39 inches over 1 centimeter. And here you have 1 kilometer over 0.621 miles, or 0.621 miles over 1 kilometer, km, kilometer, okay? Next, we have 1 pound over 454 grams. And the other one is 454 grams over 1 pound. Okay, similarly, you will have 1 liter over 1.06 quarts, or 1.06 quarts over 1 liter. So these are the conversion factors of the given equalities, okay? Those equalities could be either metric conversions, or it could be metric to US conversions. So either way, so these are the two conversion factors you're going to set up. Now, besides this, other conversion factors also that relate to density. Now, density is, for example, density is 1.0 for water is, let's just do this way. Density is mass over volume. Okay, so the mass is in grams and the volume is in milliliters, or the mass is in grams and the volume is in centimeter cube. Centimeter cube in the case of solids, because you can take a ruler and measure it. Milliliters is going to be in liquids. Okay, milliliters is for the liquids. So what is this meaning of that? Let us say something has a density of 2.7. 2.7 grams per milliliter. Let us say this is the density of some object. So this thing can be converted into equality. This means that 2.7 grams is equal to 1 milliliter. So this is how the density formula is like arranged or spread out into the equality. Okay, next is, this also means 2.7 grams over 1 milliliter, or 1 milliliter over 2.7 grams. Okay, so these are the two conversion factors from the density. Now let's do some problems here. Okay, now let us say you are given, give me 1 minute. Let us say that you are given well, let's see, give me 1 minute. I think I have a problem here writing the conversion factors. Okay, let us say you are given the US metric system, which is 1 kilograms. So this is given to you. This is given, or it is known, you know, either way, or it's in the table, and that is 1 kilogram is equal to 2.20 pounds. Okay, 2.20 pounds. So the question is asking that if you have 3 kilograms, okay, how many pounds is that? How many pounds? How many? So, you know, I mean, you can do some mental math and you can get some of this is easy, but let's say if their question is asking you, do this problem using the conversion factors. So how are you going to set this up? So first of all, for the equality, 1 kilogram over, and again, you don't have to do it all the time. You can, this is going to come with practice. So 2.20 pounds or 2.20 pounds over 1 kilogram. Okay, and then now, which one are we going to use? We need the pounds. So therefore, we are going to use this one because we need the pounds. So pounds have to be in the numerator and kilograms need to be canceled out. So now next thing we're going to write is 3 kilograms. This is given to us, or it's kind of like with the entity that we need to find, So here's your 2.20 pounds because that's the unit you need and you want to get rid of kilograms. So this is how, you do it. So next would be kilograms and kilograms cancel out. And you are left with 3 times 2.20 over 1. So this becomes 0, 6.6. So 6.6 pounds. Always write down the units. Okay, so this is one way. Next, let's look at a few more examples. This is one example. Let's look at some other examples. And that is, let us say you are given, yeah, 85 kilometers. Somebody is running a race, or the speed of a car was 85 kilometers per hour. Okay, so this becomes 85 kilometers is equal to 1 hour. Okay, and this, again, the two conversion factors are 85 kilometers over 1 hour or 1 hour over 85 kilometers. All right, so let us say there's a question in which they are saying that 60 kilometers is going to be how many hours? In how many hours can you cover 60 kilometers? So what you're doing here is you're going to set up the problem where you're going to put 60 kilometers that is given, multiply by, we need to get rid of the kilometers. So kilometers unit is at the bottom. We need to find the hours. So that's going to be on the top. And we know that 85 kilometers and 1 hour are related. So here you are going to cancel the kilometers and kilometers. And you are left with 60 times 1 divided by 85. So let's just do the math here. So here the answer comes out to be 0.70 hours. So slightly less than 1 hour, okay? So next is, let's look at some other problems, which are, let us say, some other problems are also, you will see it in the medical field. Let us say you have 500 milligrams of tablet, 500 milligrams of aspirin, ASP, I don't know if the spelling is right, but anyways, aspirin tablet, okay? So this aspirin tablet contains like 500 milligrams. So this means that one tablet is equal to, 500 milligrams. Or you can also, this is also can be written as 500 milligrams per aspirin tablet. What is the meaning? What does this mean? This is how it equates. Then you can, if you need to find out, like for half a tablet, how much is it? So half a tablet is 0.5 tablet, that's half, okay, times the conversion factor that gets rid of the tablet. So now see, I don't even have to write the conversion factor. I can just, I know it, tablet and tablet will cancel, and milligrams of the medicine is going to be on the top because we need to find how many milligrams are there I'm sorry, I didn't write the question. So 0.5 tablets will have how many, how much of aspirin? Okay, so this is the question. Okay, so here we know from the equality that 500 milligrams is present in one tablet. So half the tablet is going to be how many? So we see that this tablet and this tablet cancels out, and we are left with 0.5 multiplied by 500, and that comes out to be 250 milligrams. Okay, so this is the way you do. Okay, next, let's look at a few more examples. This is the parts to whole. This maybe you may not like see many examples of this, but that is what it is. So anyways, so here is your parts to whole problem. So what does this mean? This relates to the percentages. Okay, so let us say something is given 16%. 16%, 16% of something. Let me just come up with that. 16% of fat by mass. Okay, so what does this mean? This means that 16 grams of fat is present in 100 grams of total body weight. This is what it means. 100 grams of total body weight. Okay, so that's the total mass. And again, you can flip it. So 100 grams is the total body weight, okay, total body mass, and over 16 grams of fat is present. Okay, and so these can be used to find these conversion factors can be used this way to find the unknown. So let's look at the conversion factor in which we are trying to convert. Okay, let's look at this one. Let us say this is one example. And in this example, we see that one example. Okay, here you are given, 1 minute, break weighs 100. So if one person weighs 144 pounds, okay, what is the weight in kilograms? What is the weight in kilograms? So in the metric system, it's just grams and kilograms, and then it's the thousands, and multiply by 1,000, multiply by 100, those things. But this is clearly a US to a metric system. Okay, going from this is the US, the pound is the US system, and kilograms, that is that kilo word, that is the SI system, or this is also called a metric system. And then this is what it is. But okay, so now we are trying to look at if what is the relationship. Now this is again going to going to be given to you, or they're going to be in the tables, or when you're doing the homework you can check it out the table, or just look into the Google. It doesn't matter. But how much? So we need to know this. This is known. What is known? The relationship between the pounds and kilograms. So 1 kilogram is equal to 2.20 pounds. 1 kilogram is 2.20 pounds. Okay, so again, the two conversion factors: 1 kilogram over 2.20 pounds, or 2.20 pounds over 1 kilogram. Okay, now the question is asking that 144 pounds. So what will you do now here? 144 pounds. And we need it in how many kilograms is that? Okay, so what will you do here? You are going to convert the pounds to kilograms. So we know that 1 kilogram over 2.20, excuse me. Okay, so here you have pounds and pounds cancel out and you are left only with the unit of kilograms. So when you do the computation, it's 144 divided by 2.20, and that is 144 kilograms. Okay, so the answer to this one is 65.5. Okay, 65.5. So 65.5 kilograms. All right, let's look at where two conversion factors are used. So the two conversion factors that can be used is, to get an example of that one. So give me 1 minute here. All right, now let's look at an example of two conversion factors. Now here, let us say you are given a length of a baby 450 millimeters, and we want to convert it into inches. So there is no direct conversion between millimeters and inches. So millimeters, there is no direct conversion between millimeters and inches. And you can check this in the tables that are given to you in the handout or in the, online anywhere. So you will have to go through a indirect method, or in other words, through two steps. One is take the millimeters and convert the millimeters to centimeters and convert the centimeters to inches, because there is a direct relationship between the centimeter and millimeters and centimeter and inches. But it's both the so you have to go through the centimeters. Okay, so now what are those equalities that are known? So what do we know? We know that 1 centimeter is equal to 10 millimeters. So this is something, that is known. The second thing that is known is 1 inch. 1 inch is equal to 2.54 centimeters. Okay, so clearly you see the centimeter is common to both and centimeter is going to be canceled out. So now here, these are the two conversion factors, 1 centimeter over 10 millimeters, and the other is 1 inch over 2.54 centimeters. Okay, now what do? We see here that sorry, we have to write the other one also. So 10 millimeters over 1 centimeter. And here you have 2.54 centimeters over 1 inch. Okay, so now you write down your given, which is 450 millimeters. So 450, let me change the pen. Okay, so here we are 450 millimeters times, now we need to get rid of millimeters. So that unit is going to be in the denominator, and the relationship between the millimeters and centimeters. So this is the one that we are going to use this one. Millimeters is in the denominator and centimeter is on the top. So 1 centimeter is 10 millimeters. And then now we want to get rid of the centimeter. So centimeter goes in the denominator, and the numerator is going to have the entity that we need, and we need the inches. That is what the question is asking. And now you fill in how many centimeters. So we see that 2.54 centimeters is equal to 1 inch. So we are going to use this one. Okay, so this gives you 450. So this cancels out, actually cancels out millimeters and millimeters, centimeters and centimeters, and you're only left with the unit of inches, and that's what you need. This is what you're looking for. Okay, so here you're going to write down 450 times 1 times 1 divided by 10 times 2.54. And when you solve this, this becomes 18 inches. Okay, so this is your answer. Okay, now the last piece is using the density. So 6 and then 7. Using density. Okay, so here is your using density. How do you do this one? Let us say you are given the okay, so you are given density of some object which is 68.60, and this is actually the amount. This is the grams of zinc. Some zinc, this is a tablet or a zinc ball, you can say little beads, beads of zinc. So they weigh zinc beads. They are weighing 68.60 grams. And the amount of volume, the space that they occupy is 9.5 milliliters. 9.5 milliliters. Okay, so how did we get to? So here's the thing. This part right here, you take the weight on the weighing machine. Just like you take the weight when you go to the grocery stores, you put the food on the, you produce on that counter, and then the needle rings and it tells you how many pounds did you weigh. Same thing, you take the weight of the zinc beads, put it in the weighing machine, read the weighing machine, and you're done. So you know the weight is 68. Now, but how do you, 68.60, but how do you get the volume? So for the volume, here's the method. So here is the graduated cylinder. Okay, and this is a glass graduated cylinder, and this is labeled obviously. And so here you will read, let us say, the initial reading. Here, this is like this, and then it has all these weights, like all these markings, sorry, not a weight, and this is milliliters. So now you fill this up with water up to a certain level. So here you filled it with water, first of all, and you make an empty reading, like a plain reading, okay? Make a plain reading of this here. So this is the water, just plain water. And now you add these beads and you notice, let's say you have these zinc beads, and now you start dumping the zinc beads, sorry. Start dumping the zinc beads here. So all these zinc beads are, put here. So as the zinc beads go, they are going to take their own space. And when that happens, the level of the water is going to rise up. So this is going to be, this was the initial volume, volume 1, and this is the final volume, volume 2. And that amount of water that rises depends, what the, so here, this is the above. So what the amount of space that object is occupying. Okay, so it's basically V2 minus V1, and that's going to give you the volume in milliliters of the objects. And the object in this case is the zinc pellets. So small, like, beads. Okay, so that is measured as 9.5 milliliters. So you take the final volume, you take the initial volume, and you find that difference. Okay, so this is how they determine. So now what is the density? So here's the density of zinc, density of zinc. Density of zinc is 68.60 divided by 9.5. So this is grams and this is in milliliters. So the answer comes out to be 7.2 grams per ml. Okay, so this is one thing. But you can also find, the density is going to remain consistent But using the density formula, if you know the density, you can find the mass or you can find the volume. Just like you can get the density using the mass and volume, same is the case. If you know the density, you can either find a mass or you can find a volume. Okay, so this is one thing. And when we say 7.2 grams, it means 7.2 grams is equal to 1 ml. And then the other equality becomes 7.2 grams over 1 ml or 1 ml over 7.2 grams. So let us say one example is there is 5 grams of zinc beads. Okay, and we want to find that what is the volume of these. Okay, so here density is known. Density is equal to mass over volume, and the mass is 5, so density is 7.2 grams. So 7.2 grams. So this is algebraic conversion. 7.2 grams is equal to the mass is 5 grams over the volume. Okay, and that volume is going to be in milliliters. So next thing would be that we want to get rid of the volume, or in other words, volume in milliliters is equal to 5 grams over 7.2 grams. Okay, so let's solve this one. Okay, so this comes out to be 0. So the volume in milliliters is equal to 0.69 milliliters. Okay, so this is using the conversion factors, and pretty much once you have the density, you just have to split it into the conversion factors, then you can find any of the unknown entities as well. So we are going to stop here, and I'm hoping it was easy. And thank you for watching. Take care. Bye-bye.